Okay, so let's see. Let's go back to do a couple of these. Say num list, and let's pop off Bob. Num list pop, and it will remove Bob, but it should also return the value, and it does. And we say, well, show me num list now, and so there it is. And so now we're going to say we've got to import random to use these functions, right? Whoops, I'm sorry. You got to import random to use these functions. And then we do something like this. We say, again, remind us what it looks like. There it is. Looks like that. 15, 5, 15, 84, and so forth. And then we're going to say, we're going to invoke the choice function. But to do that, because we imported it, we have to say the namespace where it was imported, which is random. And does it return a value? Yes, it chose one of the, randomly chose one of them. If we repeat it again and again, every time it returns not necessarily a different one. It is so far. I'm not sure. I think it's doing it with replacement. There we go. We get 14 twice. There are two 14s. Or if we use random shuffle, that is the function shuffle in the random module, and then notice it didn't return a value, but that num list has been permanently reordered or permuted, if you will. Okay, if we do it again, and then we say, show me what num list looks like now. Again, it's been permanently changed. So you got to kind of keep track of which of these functions return a value, which is what I'm used to, or which one of these functions permanently change the structure of the object that you're dealing with. In this case, a list. Okay, and if that's not confusing enough, and it's not that confusing, you can make shallow copies and deep copies of things. What does this mean? Well, in a shallow copy, let's look at what's going on here. Okay, so here I'll call it up too. Shallow copies change the item plus any other items that it refers to. What does that mean? Well, so this will execute all of this stuff. We are going to use, I'm not sure why we're importing random, but we are. Oh, because of copy. No, I don't think we have to import. We don't have to import random, but we do it on the slide anyhow. We do have to import copy, right? Because deep copy is a function that's in the copy module. Okay, well, let's just look at the code real quick. So here we make list one equal to this 1, 2, 3, 4, 5. Then we just simply copy over, make a so-called shallow copy of list copy of list one into list two. So list one and list two look the same, right? And then we make a change to list two, right? We change the value of this element in list 2 only to 4. But notice what happens. It not only changes the value of the second item in list 2, it also changes the value of the second item in list 1 that it refers to up here. So it made the change to both list 2 and list 1. Okay, and that I find that, I'm not sure why you would use that. In fact, I would think you don't want to do that. So if you don't want to do that, you want to make a what's known as a deep copy in Python. And what a deep copy does, it avoids this. A deep copy, if we make list 1 this value, and then we make a deep copy of it to list 2, when we change the second value in list 2, it has no effect at all on list 1. List 1 is unchanged. Okay, so that's a deep copy. A deep copy, items that are referenced to it don't change too, right? So run that, you can see, if you go back and look at the slide, you can tell it's working. But again, I find that if not confusing, I wonder about why you would want to do that, but there must be a reason. Okay, what else can you do with a list? You can slice a list, and slicing a list just extracts particular elements. Okay, and the general syntax is a starting value, which I think has a default of 0. These are indexes, an ending index, and a step, right? So if we say numbers consists of this list, and then we slice it starting at the 0th index to index number 2, it excludes the end. Okay, and this, you got to keep this in mind. It goes all the way up to the end, but it doesn't include that one. So we just get these 2 numbers. Or if we leave the start blank and up to 2, we get the same result, because it returns the 0th index, which is this one, the 1 index, which is this one, and then it stops. Or we can start at the 4th index and leave the end blank, in which case it will start 1, 2, 3 here and return 60 and 62. Or you can go backwards. Okay, the step argument, this one would do every other one, starting at the 0th, right? So we get this, we would get this, and it stops just before this, so you don't get 60. Or if we do it like this, where we leave start and end empty, but we say we want to start at the -1th, that's this one, and it just walks backwards, prints it back backwards. Okay, so that's slicing a list. You can also concatenate. And again, I have all these on slides, but for the sake of time, we'll just look at, I have them in scripts, but for the sake of time, we'll just look at the slides. Right, so we create an inventory list, and we create a chest list. And here we concatenate them, the 2 lists together using plus, and it permanently creates this new list combined, which has all 4. Notice that inventory is unchanged, as is chest. If we print chest, we'll get only the chest items. Okay. On the other hand, if you use this, I forget what it's called, I call it the incremental assignment, it will permanently change inventory. We're adding individually, here's inventory to begin with. We're individually adding first scroll to inventory, and then we are individually adding pestle to inventory. And inventory is no longer this. Inventory has been permanently changed. And again, these are lists. Lists are mutable, so you can change the values in them without creating a new variable, a new list altogether. Let's do a couple more. I think we'll get to tuples next time. So map and filter. Let's see, what does map do? Map maps the items in an existing list to items in a new list. To do that, this code defines a function named square, right? So here's num list. Let's run this. Go over to the slide. This is 46.